Welcome to this week's superhero simulation. This week we're going to be using Autodesk Nastran In-CAD to run a linear static stress analysis on Thor's hammer. As always, if you have any questions, feel free to hit me up directly at james.herzing@autodesk.com, follow me on Twitter at Mr. Simulation Rocks, or follow our Autodesk Simulation Twitter handle. As we know, Thor comes in many shapes and sizes. The big blonde guy in a movie, the little blonde girl at Comic-Con, or even the one in the comic books. The one thing that they all have in common, though, is the hammer. So there are a few things that we're going to have to take into consideration and make assumptions about for our analysis when it comes to this hammer. Since it's not any ordinary hammer, it has a bunch of special abilities, it seems. One, it's hard enough to crack Captain America's nearly unbreakable shield. So it's very strong, but we don't really have those material properties, so we'll have to make those up. He also swings with the strength of a god, and since this is going to be a linear analysis, we're not actually going to have any motion. And last, it has a lot of cool engravings on it that we're going to remove for the sake of meshing and a faster analysis. So with that, we're going into Inventor to start, where we have our model opened, and from this we can then just jump into the Environments area and start our analysis. You can see first off though that I've already split a surface so that we have a place where Thor would be holding his hammer. So that's where we can add our boundary conditions. So in Environments we go into Autodesk Nastran In-CAD and we can work left to right here. Starting with New, we can go in and define our analysis name and title, choose what type of analysis we're going to be running, which is going to be linear static stress. Look at our nodal outputs available, and choose what kind of output we want, such as stress, to see if our hammer is going to break. We also can define what kind of contact we have for our model, which bonded is perfect. Let's click OK, and then go ahead and move to Material. This is where we can assume that we're working with something real versus what it's actually probably made of in the movies, or comics for that matter. Let's scroll through here, and we're going to go pick A36 steel, close, and then we can click OK. So you see all of the properties are automatically filled in there. And then let's go check out Physical and see that we're working with solid elements. They're not shells or anything like that. Click OK. And now we can apply our constraints and loads. So clicking on constraints, we can select the handle and see that all of the degrees of freedom are checked. So we have the handle fixed where Thor is going to be holding it. And now if we rotate it around, we're going to select this top surface of the hammer, or front surface of the hammer, for our load. We're going to be applying a force on it, and after selecting the surface, we see that the straight-on loading would be in the X direction. So let's go ahead and type in something, I don't know, relatively small for how hard he swings this thing. Let's call it, I don't know, 2,500. 2,000, how about that? That's a little bit easier. And click OK. So we now have our loads and our boundary conditions on there. Let's define contacts. So this is necessary if you have a number of parts in your model. It can automatically detect those contact sets for you, and it would define them as bonded, as we said. And now we can look at our meshing parameters, clicking OK, and finally we can choose to run the analysis. You can see it automatically meshes it for us, and quickly it will analyze it and give us our results. So here with the results, we can right-click on von Mises and choose Display, and it will show us that, as we expect, where the handle is bending is where we have our highest amount of stress. We also can see how the hammer is deflecting, as we would think. Where we push on that front face, it's going to move back. So everything seems pretty logical at this point. But let's go ahead and edit our legend so that we can see a little more stress in the hammerhead. So let's choose to specify a min-max and make the min 0, and the max, if we make it, say, 1,000 and click OK, and then display our von Mises stress again, you can now see that, yes, the shaft of the hammer is the highest stress, but you can also see the loading on the head as well. If we display the displacement, you can see how far it's deflecting, so almost ½ of an inch, not so bad for a giant steel hammer, and back to stress we go. So that's all there is for a static stress analysis. Hopefully you've learned something here with Thor, and we'll catch you again next week.